This video is a brief introduction to the periodic table of elements and in particular how the table is organized. First of all, what is the periodic table of elements? If you've never seen it before, it can look a little complicated. There are a bunch of boxes, a variety of colors, different symbols and numbers. What do all these colors and symbols and numbers represent? Well, at its heart, this table is a list of every known atom in the universe. Every known element in the universe is in this table. Everything that exists is made of stuff, and that stuff is made of atoms, is made of elements, and this table is simply a catalog of all of those elements. The table has 18 columns and 7 rows. This is column 1, column 2, etc., all the way down to column 13. And this is row 1 and row 2 all the way down to row 7. The columns are called groups, and this is group number 1 here. This is group number 2, group number 3, all the way over to group 18, and the rows are periods. This is period 1, period 2, period 3, all the way down to period 7. Now, you might be wondering, why is hydrogen at number 1 and helium at number 2 and lithium at 3 and so on and so forth, and oxygen, for example, oxygen. Why is oxygen at number 8? Oxygen is so important for life. Shouldn't that be at number 1? Well, the reason for that is because of the way atoms are made. Atoms are made of 3 different subatomic particles. Protons with a positive charge, neutrons with no charge, and electrons with a negative charge. These are the 3 subatomic particles that make up atoms. If we were to look at a picture of a basic atom, in its nucleus are the protons and neutrons. Protons are positive, neutrons have no charge, and orbiting the nucleus are the electrons with a negative charge. Now, if we had an atom of a particular element, and that particular element had 1 proton in its nucleus, that would be an atom of hydrogen. That is the deciding factor of what makes an atom of hydrogen an atom of hydrogen, because it has 1 proton in its nucleus. It does not matter how many neutrons and electrons there are. There could be 1 or 2 or 3 neutrons or 1 or 2 or 3 electrons. It would not matter. It still would be an atom of hydrogen if it had 1 proton in its nucleus. If an atom had 2 protons in its nucleus, that would be an atom of helium, regardless of the number of electrons and neutrons. Similarly, an atom of oxygen always has 8 protons in its nucleus, regardless of the number of electrons and neutrons. So that is the deciding factor. And these numbers here are called the atomic numbers. This is the atomic number of helium. The atomic number of helium is 2. The atomic number of aluminum is 13. Aluminum has 13 protons in its nucleus, and it has the atomic number 13. That is how an atom, that is what makes an atom a particular element, the number of protons in its nucleus. Now, the table of elements also has some other interesting features. For example, for the most part, with some exceptions, all of the elements in a particular group have the same properties. All of the elements in group 1 have the same properties with the exception of hydrogen. Hydrogen is a little bit of an oddball there. All of the elements in group 2 have the same properties. All of the elements in group 3 have the same properties. And one way to think about this is, let's say someone were to give you 3 different sets of objects and asked you to arrange them in some fashion. Let's say they gave you 3 different sizes of pyramids, 3 different sizes of spheres, and 3 different sizes of blocks. And they asked you to arrange them in some way. Well, what you might do is simply arrange them in columns, in groups, like this. You would put all the blocks together, you'd put all the spheres together, and all of the pyramids together. And this way, you could keep track of all of the objects quite easily. First of all, they're clearly labeled, nice and easy. If someone were to give you a new member of one of these groups, for example, another sphere, you would know right away to put that in that group. If someone were to ask you how different arrangements of these objects would behave with each other, for example, if someone said, well, let's put a sphere on top of a block, you would know that if you placed it there with a little bit of care, it would simply rest on top. It wouldn't roll from side to side. On the other hand, if you were to have a pyramid and put a sphere, place a sphere on the edge, you know that that would roll down and not remain on the edge of the pyramid. And that is more or less the same way that the elements in the periodic table are arranged. These elements over here are highly reactive, and they want nothing more than, for example, to react with all of the elements over here in column 17. Group 17. Group 1 elements, with the exception of hydrogen, would love nothing more than to react with group 17 elements. And this illustration here kind of gives you a brief sort of overview as to how that works. Let me just get rid of this briefly. There we go. Now, getting into a little more detail, group 1 are called the alkali metals. As I said, these are very, 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 very reactive elements. Want nothing more than to react with other elements in the periodic table, particularly those elements in group 17. These are highly reactive. They have low melting and boiling points. They're very soft and silvery. You could cut them with a butter knife. You're not going to find, because these are so highly reactive, you won't find them out in the open. You can't just walk outside and see them. They have to be contained in special containers because they want nothing more than to react with other elements. In the second group, we have the alkaline earth metals. These also are reactive, but not quite as reactive as the alkali metals. Not quite as reactive. These are the alkaline earth metals, and they are all of these right here. And let me also just go back over here and show you that these are all of the alkali metals right in here, not hydrogen. Hydrogen is not one of the alkali metals. It's one of the group 1 elements, but not one of the alkali metals. The next block are the transition metals. The transition metals are all of the ones from group 3 to group number, it's not very well done. Let me do that again. From group 3 over to group 12. These are the transition metals. As you could imagine, transition metals are good conductors of heat and electricity. They're less reactive than the alkali metals. Just like the alkaline earth metals, they're less reactive. But you could form these. They can be, they're ductile, and you can work with them. The next group are the basic metals. These include such things as aluminum and gallium and indium and tin, and these are all the ones in this area right here. Right over here are the basic metals. Here we go. These are the basic metals right over here. And then we have the halogens. These are the group 17 elements. These are the group 17 right here. And as I said, they love to react with the group 1 elements. They love to react with the group 1 elements. These right here are called the halogens. Halogen means salt forming. Salt forming. And if you think about it, sodium and chlorine form sodium chloride when you put them together, and sodium chloride is salt. That's the salt you put on your food, and that is what halogen means, salt forming. And the final group are the noble gases. The noble gases, they have such a noble name because they don't react with anything else. They are inert. They're so kind of cool. They're cool characters. They do not react with anything. They are inert, and that's why they are called the noble gases. Well, that is essentially an overview of the periodic table of elements and how the table is organized. I hope that has given you some introduction and it has been of use to you. Thank you.